There's lots of different ways to measure how concentrated a solution, and in this screencast we'll take a look at several, 5 at least, ways to measure the concentration of a solution. This is screencast 11.6, and by the end of this you should be able to describe those ways that we can measure the concentration of a solution, be able to use them, and ask yourself, why are there so many methods? We'll think of which method is appropriate for a given end use. Screencast 11.6. Concentration. Here's several different pieces of data for solutions. Looks like it's generally sodium chloride and water. We'll think of the type of measurement that's being used and how concentrated it is. And we'll look at the general formula for measuring each one. These formulas would always be given to you on a test. If you got 10 grams of sodium chloride and 90 grams of water, this is a percent by mass solution since we have masses in each case. And this is 10% by mass. Notice it's not 11.1% by mass. That's because the definition is, the formula is mass of the solute, 10 grams, over mass of the solution, not 90 grams, 100 grams. Solution is solute plus solvent, times 100 to make it a percent. Here we have 10 mils of juice and 90 mils of water. That's percent by volume, since we have volumetric measurements in both cases. Once again, it's 10%, and don't forget that it's the volume of solution on the bottom, not the volume of the solvent. So 90 plus 10 on the bottom, making it 10 divided by 100 times 100, give you a 10% solution. If you have 58.5 grams of sodium chloride in 1 liter of solution, I suppose you're looking at a molarity solution. Since 58.5 grams is a specific number, that is 1 mole of sodium chloride, 23 plus 35.5. A liter of solution, that's the volume, so it's a 1 molar solution because molarity is defined as the moles of solute, 1 mole in this case, divided by the liters of solution, 1 liter in this case. 1 divided by 1 equals 1. Occasionally you'll see a molality solution. This is 58.5 grams of sodium chloride in a kilogram of water. They gave you the mass of the solvent. This is oftentimes used for colligative properties such as freezing point depression and boiling point elevation, which we'll get to later in this unit. This is a 1 molal solution. Little m. Notice the tiny little difference. Big M, little m. It's the moles of solute, which is 1 mole in this case, divided by the kilograms of solvent, which is 1 in this case, so it's 1 molal. And perhaps the most obscure of these is the mole fraction measurement, which you're given grams in both cases, but they want them both to be converted to moles. So this is defined as the moles of solute, 1 mole in this case, divided by the moles of solution. Looks like 9 plus 1 equals 10. This is 9 times 18 is 162. It's 18 short of 180. And so you have 1 divided by 10, or a 0.1 mole fraction solution with the symbol X. This is screencast 11.6.